Okay, hello everyone, it's Salar and we are in part 56 of our tutorial, a tutorial to writing a real-time operating system. But this part 56, is the last part of this tutorial. After this tutorial, the implementation of RTOS will be completed, okay? And you have first version of the RTOS, okay? But in previous part, I implemented the MATEX and I said MATEX is a locking mechanism like semaphore. Okay, but in this part I want to implement rest of system calls in thread.c. Okay, for thread remaining system calls. If you see and if you visit the repository of project under commit number 14, I've implemented rest of the system calls in threadSetPriority, threadYield, threadSuspend, threadResume, and threadTerminate. Okay. Under this commit implementation rest of thread system calls, I've implemented other system calls in the thread. Okay. But let's do our job. Let's do our business. I want to implement these threads. First, threadYield. Let's implement threadYield. Let's see the implementation of threadYield. threadYield is a simple system call. What does this system call do? Request a context switch. To request running next thread in ready list, you must use threadYield. Okay. But let's see the implementation of this thread. In thread.c, you have thread.yield. This system call doesn't have argument. You just send current running thread, okay, thread that's called threadYield to the kernel space, okay, and in kernel space, if the RTOS running the color thread, request for context switch. Okay, it's so easy. Let's see an example. Okay, this is the example. I have I want to create two threads, thread 1 and thread. Both of threads have the same priority. Okay, have same priorities. Okay, priority normal. But as you can see, creating thread 3 commented. Okay, but we have just two threads, okay, with priority normal. But if I run the project, RTOS jump to thread 1. But if I run threadYield, RTOS immediately jump to next thread in the ready list. Jump to thread function 2. Another time, after context switch, return to thread function 1. A simple system call. Okay, this is threadYield implemented. So let's return to the slides. Now let's talk about threadSetPriority. By using this system call, you can change priority of a thread. But what does this system call do? This system call checks the state of thread. Okay, if thread is running already, just change priority list of thread. Okay, remove from a priority list and insert to another priority list. Change the priority of the thread. You can see here threadSuspend. You can't call this function from interrupt by threadSetPriority. Get the stack size, and here is set priority. Okay, you can change the priority of this thread, change to this priority. Okay, we can't call this system call from interrupt. And like other user space system calls, send its argument to the kernel. Okay, and after that, if new priority equal to old priority or current priority, just return OK. Okay, otherwise, if thread state is running or if thread state is ready, delete from ready list, change the priority of thread in thread control block, and another time insert to next ready list. Okay, insert to new ready list. And by using of this line, these lines, check for context switch. Check context switch is necessary or not. Study this line by yourself. It's a simple part. Okay, study this line by yourself. But let's return back to the slides. After that, if a state of thread is weighted, state of thread is weighted, if thread inserted to semaphore or matrix waitlist, you know the semaphore and matrix waitlist is a binary tree data structure, and this binary tree is an ordered data structure and ordered by priority of threads. Okay, if thread inserted to semaphore or matrix waitlist, reinsert thread to the semaphore or matrix waitlist by new priority. New node key. Okay, you must change the key of node in binary tree. Okay, because binary tree ordered by key, and key is priority of threads. Okay, so let's see the code. Okay, if state of thread is weighted, check. If weighted for semaphore, delete from semaphore list, delete from semaphore list, change the priority, change the key of these nodes, semaphore wait node and matrix wait node. Change the key to new priority, and another time insert to semaphore wait list by new priority. If waited for matrix, delete from matrix wait list, change the priority, change the key of these nodes, and for matrix reinsert to matrix wait list by new priority. And if thread has not been inserted in semaphore waitlist or matrix waitlist, just change the priority of thread and return status OK. Okay. After that, if a state of thread is suspended, in next slide I get into suspended state, and I say you what is suspended state. Just change the priority. For this part is easy. If a state is suspended, just change the priority and return OK. If thread state is terminated, terminated state means deleted state. A terminated thread is a deleted thread. You can't change the priority of deleted thread. Return error. Okay, return an error. Okay, this is the set priority. Let's see an example. Okay, this is the example. I have thread 1 and thread 2 with priority normal and thread 3 with priority high. Because priority of thread 3 is higher than other priorities, after running of RTOS processor and RTOS jump to thread function 3. But I want to change the priority of thread 3 to lower than priority 1, thread priority 1 and thread priority 2, thread 1 priority and thread 2 priority. Okay, if I run the system call, immediately the RTOS immediately jump to thread function 1. Okay, and after the system call, the RTOS doesn't run thread 3 anymore because has lower priority than thread 1 and thread 2. Okay, so by using a threadSetPriority, you can change the priority of the thread. Very good, very good. Let's return to the slide and inspect other system calls. The next system call is threadSuspend. But what does this system called threadSuspend do? By threadSuspend, you can stop running of a thread for an unspecified or unlimited time. Okay, by using a thread wait, you stop running of a thread for a specified time, the delay time. Okay, the delay time. But by using a threadSuspend, you can stop running of a thread for a specified time, and after suspending a thread, you can return the thread to the ready list just by threadResume. Okay, so threadResume resume the suspended thread to the ready list. Okay, but when you suspend a thread, okay, run threadSuspend for a thread by using this ID, by using this argument ID, RTOS delete this thread from ready list and insert it to suspended list. Suspended list is a new data structure. Okay, new data structure is a simple queue. When you suspend a thread, RTOS insert thread in this queue, suspended list. If you check the list.h, you have some manipulation functions for suspend list. And suspend node is a queue node, and suspend list is a queue. Okay, and when you, for example, create a suspend list, you create a queue node. Queue list. Okay, create a queue. But to implement threadSuspend, you must implement suspended list in kernel and suspended node for each thread, because when you want to insert thread to this queue, thread needs to have a node. Now here in RTOS include and RTOS type definitions. In a state of threads, we have two new states, suspended and terminated. When you suspend a thread, RTOS change the state of thread to thread state suspended. Okay, and if you check kernel control block, you have suspended list here. Okay, insert to this list. Suspended list will be inserted to this list, and for each thread you have a suspended node. Okay, by using of this node, insert thread to suspended list. Okay, but let's to inspect threadSuspend. threadSuspend, like threadSetPriority, check the state of thread. If the state is running already, just delete thread from ready list and insert it to suspended list, to this queue. Okay, here. threadSuspend, threadTerminate, threadYield, and threadSuspend. Okay, the thread just have just one argument, an ID. You want to suspend the thread by this ID. Okay, you can't call this a system call from interrupt. Okay, send this ID to the kernel space to suspend this thread, and in kernel space check if thread state is running already. Just delete from ready list, delete thread from ready list and insert it to suspended list, and change the state of thread to suspended. And if context switch is necessary after deleting a thread from ready list, request a context switch, request for context switch. So easy. And if state of thread is waited, if thread waited for a semaphore or mutex, delete the thread from semaphore or mutex list. Okay, after that delete thread from kernel wait list and insert it to suspended list. So first check for waiting for semaphore or mutex. Here, if a state of thread is waited, if waited for semaphore, delete thread from semaphore wait list and change this member to null, because after suspending a thread, the thread has not waited for a semaphore anymore. Okay, change this value to null. If waited for mutex, delete from mutex wait list and change this member of thread control block mutex waiting for to null. Okay, and after that delete thread from kernel wait list and insert it to suspended list and change the state to suspended. Okay, and suspended state and terminated state is easy. You can't suspend a suspended thread. If state is suspended, return error, and if thread is terminated, return error, because you can't suspend a deleted thread. Terminated thread is similar to a deleted thread. Okay, so let's do see an example. Okay, another time I have this example: thread 1 priority normal, thread 2 priority normal, and thread 3 priority high. If I run the code, RTOS jump to thread function 3, but if you check kernel control block in ready lists, in ready list number 3 for priority normal, the size is 2. We have 2 ready thread in this priority state, priority level, priority normal, thread 1 and thread 2, and in list number 5 priority high, we just have 1 thread. Okay, thread 3 has high priority, has priority high. Okay, if I suspend thread 3, RTOS immediately jump to thread function 1. If another time, check the kernel control block, ready list, another time. For priority normal we have 2 threads, but for priority high we have no thread because thread 3 deleted from ready list and inserted to suspended list. And if you check the size of suspended list, the size of suspended list is 1 because thread 3 inserted to suspended list. Okay, in this way you can use threadSuspend. Very good. Let's return to the slides. After threadSuspend, threadResume. threadResume is a simple simple system call. I said when you suspend a thread, you can return thread to the ready list by threadResume. What's the responsibility of threadResume? Returning a thread from suspended list to ready list. So let's see the code. threadResume. By using of the thread ID, you can resume a thread from suspended list to ready list. Check if the state of thread is suspended, delete thread from suspended list and insert it to ready list and change the state of thread to ready. For other states, return error because by using a threadResume, just you can resume a thread from suspended list to ready list. Let's see an example. Okay, another time, this example, thread 1 and thread 2 with priority normal and thread 3 with priority high. First, RTOS jump to thread 3. If you suspend thread 3, RTOS jump to thread 1. But if you resume thread 3, another time, RTOS jump to thread 3. Okay, so easy. By using a threadSuspend, you can stop running of a thread for an unlimited time, and by threadResume, you can resume that thread to the ready list. Okay, let's return to the slides and the last thread. The last system call. I'm so sorry, the last system call. By using a threadTerminate, you can stop a thread permanently. When you terminate a thread, you can't return the thread to ready list anymore. Okay, but you can't terminate a thread that owned a mutex. When a thread lacked a mutex, you can't terminate that thread. First, you must unlock all of owned mutexes. After that, terminate a thread. Like suspended list for threadTerminate, you must implement terminated list in kernel and initialize this list in kernel and create a terminate node for each thread and initialize this node when you create a thread. Okay, but let's see threadTerminate. User space system calls like others, but if the size of thread on the mutex list is greater than 0, this means there are some owned thread in this list. okay, and you can't terminate this thread, and at this situation, in this situation, thread terminate return error. Okay, otherwise like other threads, like other system calls, you must check the state. If a state is running already, just delete thread from ready list and insert it to terminated list like threadSuspend. If running already, delete from ready list, insert to terminated list, change the state to terminated, and check for context switch after deleting a thread from ready list. Like another time, like suspended, if thread state is waited. If thread waited for a semaphore or matrix, delete thread from that list, semaphore or matrix list. After that, delete thread from wait list and insert it to terminated list, completely like threadSuspend. If thread is waited, if waited for semaphore, delete from semaphore wait list. If waited for matrix, delete from matrix wait list. After that, delete from wait list and insert to terminated list, and change the state of thread to terminated. Okay, and if the state of thread is suspended, just delete thread from suspended list and insert it to terminated list. If state is suspended, delete from suspended list and insert it to terminated list, and change the state. And you can't terminate a terminated thread. If thread state is terminated, just return an error. Okay, so easy. And you can use this system call completely like threadSuspend. Thread terminated, for example, terminated thread 3. Okay, but after terminating thread 3, you can suspend this thread. Okay, by using of this system call, easily you can terminate a thread and finish. This tutorial has been finished here. Thank you very much for seeing this tutorial. At this time, after 56 parts, you can create an RTOS for yourself and use this RTOS in your projects. This is the first version of RTOS, okay? But you can this RTOS in your projects because almost is a complete RTOS. But in future days and future months, I will update this RTOS. But this RTOS by itself is a complete RTOS at this time. Okay. Other operating RTOS and operating system like FreeRTOS or other real-time operating systems has more options. But this is the first version of our RTOS, this RTOS, OpenTeach project RTOS. Okay. And I invite you to help me to make this RTOS one of the best RTOS in the world. Okay, we can do this work by ourselves. Okay, with your help, I can make this RTOS one of the best RTOS in the world. I know I can do that, and you can help me, and you can do that. Very good and very nice. Thank you very much for seeing this tutorial. I will see you in the next tutorials. Very good and very nice. Thank you very much to see me, and see you soon in the next tutorial, not next part. Thank you very much.